Okay, so on this question, we are wanting to solve, well, I don't know if it's solve, it's not an equation, but we're wanting to rewrite this big log expression in this format. So basically, we're wanting to take this one log and break it into two logs. That's the name of the game. One log becomes two. So how do we do that? Well, let's refer to the log properties. So here they are. Here's the three log properties that we're going to use in this section. So, and the way these work, this is one log and this is two. And the multiplying, notice, becomes adding. Here, the dividing becomes subtraction. So let me write this out in a way that's meaningful and makes sense. So adding and subtracting are easy operations. You learned them when you were just a wee child. But then multiplying and dividing are harder operations, right? Well, notice that over here, the harder operations of multiplying and dividing give way to the easier operations of adding and subtracting for two logs. And for one log is the harder operation. Excuse me. So the first two properties, the first two log properties, basically take harder operations for one log. So for one log, you have the harder operation of either multiplying or dividing. And then it's equal to the easier operation for two people. So it's like the old saying, you know, in fact, I'll write it over here. Two logs make the operation easier, right? Two logs make the job easier. Like if you have one person doing the job, two people, it's easier. So that's basically what we're talking about. Okay, so what does that mean then? Well, coming back here, we have one log, and what do we have? We have x to the 16th, and then this big old root thing. And they're right next to each other, which means multiplication. There's no times symbol in there, but we know that's what it means, right? You write x and y right next to each other, you put nothing in between, it means times, doesn't it? So they're multiplying. So that's going to equal two logs. And by the way, the little 3, that just stays there. We're not messing with the base at all. The little base just stays right where it's at. We're not changing that at all. That's not what we're messing with. It's the other stuff. And so then this will become x to the 16th plus, and then I'll put that cube root of y to the 13th. Does that make sense first off? So the invisible understood times became adding. That's using property number 1, that when you have two logs or one log with multiplication, it becomes easier for two logs. So for two logs, right? That's what property 1 says. You have one log multiplication becomes two logs adding, becomes easier. Two logs make the operation easier. Two people make it easier. So that's my first step. There's my first step. Make it two logs added instead of one log with times in there. Now, what can we do from here? Well, look, now the root, let's go over here and talk about this root thing. What do we do with that? Well, that's what I'm giving you down here, is the fact that fractional powers become roots. You remember that? Have you seen that before? It's important in this section. Fractional powers become roots. So if you have a fractional power, that b there that's in the denominator, that guy swings around and goes into the hook. Or he can swing back and go to the denominator. Either way, just depending on what you need to do at the moment. It's like saying one or uno. You're saying the same thing in two different languages. So you can move that back and forth all you want from the denominator to the hook or back. It doesn't matter. So, okay, so what? Well, that means I can take this 3 right here and swing it back, and the root will vanish. Are you with me? Look back at the property. You see how when you take this and you swing it back, then it's equal to that with no more root. When you change it to a fraction power, the root vanishes, doesn't it? You're either a fraction power with no root or you're a root, right? One or the other. So what does this become then? This becomes log base 3 of x to the 16 plus log base 3. Let me move that there. Of what? Y to the 13 thirds. No more root. We changed it to a fractional power. So you can be in the hook or be in the denominator as a fractional power. It's the same thing. Okay, now what? Now I'm going to use property 3, which says powers can drop down to the front. See that right there? Anytime you have a power on a log, so you have a log with something to a power, you can bring that power down to the front as multiplication. Log property 3 there. So that's exactly what I'm going to do for these guys. I'm going to take this power, drop him down to the front, and this whole fraction power, drop him down front. So it's going to be 16 in the front, log base 3 of x plus, and then 13 over 3 in the front, log base 3 of y. Yeah, I'll put this back in these colors. There we go. And we've done it. We've done what? Well, we've made it the form. They wanted this and this. That's exactly what we did, right? If I put that down here, they said make it a log base 3 of x plus b log base 3 of y. We did. We made it look like that. We broke it into 2 logs with no more roots and the numbers in the front. So they say, okay, what's your a, please? Tell us what is a? Well, a is the 16, isn't it? And b is that whole 13 over 3. Like that. And so there we go. Using these 3 log properties and the root becomes fractional powers properties, we have done it. There we go.